Analogous systems. Now we will see the mechanical elements can be converted to the electrical equations. So it is called as analogous systems. So first we will see the mechanical rotation translation system. So now these mechanical elements we will convert to electrical equations. So there is a diagram where three elements are working: mass, damper element and spring element. Okay, so we'll see here spring element and this is damper element. Both are connected to this mass m. Force will be act here F2, F3, and this force is act here F. The displacement is x and velocity is v. So now we will make an equivalent system. This is F1 equivalent system. So equal force will be there. So equilibrium condition F is equal to F1 plus F2 plus F3. So F is equal to, we can represent m dv by dt plus vv plus k integration of v dt, where m is the mass, b is the damper coefficient, k is the spring constant, or we can write in terms of displacement m d2x by dt2 plus b dx by dt plus kx. These are our equations. So this mechanical transition systems we will convert to the electric systems. Electric systems, either we can go for voltage equations or current equation. So first we will go for electric systems of voltage equations. So we have a inductor, resistance and capacitor are series, is supply voltage V. So L, R and C, the current flow is I. So if now we can find out equation, apply the KVL. V is equal to V1 plus V2 plus V3. V1 will be the voltage across the inductor, V2 is the voltage across the resistor and V3 is the voltage across the capacitor. So now we can make equation V1 is equal to L di by dt plus voltage across the resistance IR plus voltage across capacitor 1 upon C I dt. So now again we can substitute by charge, because charge is equal to dq by dt. So we can substitute by charge, so we can write equation here V is equal to L d2q by dt2 plus R dq by dt plus q by c. Now these two equations we can compare. Question number 1 is a mechanical equation, equation number 2 is a electric equations. Now we can force voltage analogy. We can see here, so L is equivalent to the mass, so M is equivalent to mass and B is equivalent to R. You can see B and R both are equivalent, and K is equivalent to 1 upon C. K is equivalent to 1 upon C, and V is equal to R. And also we can see here X V is equivalent to we can see here Q is equivalent to X. Q is equivalent to X. And V is equivalent to I. So also we can see here V is equivalent to I. V is equivalent to I. So this is the force voltage analogy of mechanical transmission systems.